Hello and welcome to your class of Physical Geography. Unit 4 will be talking about the Continental Drift. And by the way, this one is going to be a shorter one, so we'll do this. So the Continental Drift, what is it? Our last chapter the structure of the Earth, we saw how the Earth was formed, layers, and we talked about the earthquakes. So it usually leads to why? Okay, why? Well, we know how, but why are earthquakes happening? Well, the short answer is the continental drift. Now, it's a little bit, of course, more complex than that. You can imagine that, but continental drift is the why it happens. So, what is it? So, the continental drift is a theory that the Earth's continent have moved over geologic time. So the speculation that the continent might have drifted was first put forward by Abraham Ortilis in 1596. So it's not something new. So in 1596, he went and said, yeah, it's a possibility that the continents are moving. Of course, he could not go further. He did not have all the technology that we had a little bit later, but there you go. So the concept was independently and more fully developed by Alfred Wegener in 1912. This theory was rejected by many for lack of any motive mechanism. So how can it move? There's no way it would move. That was the main thing about it. Why would it move? There's no reason for it to move. Now, later on, Arthur Holmes proposed that the mental convection was responsible for that mechanism. So the idea of continental drift has since been included in the theory of plate tectonics, which explains that the continent move by riding on plates of the Earth's lithosphere. So as you can see here, it was first a Pangea, right? And then it moved gradually to what we have now. So that's pretty much what it is there. Now, when we're talking about a mental convection, what are we talking about? Well, in short, in very short, as you can see here, convection is just that moving, right? And since it's moving, the example here is the mid-ocean ridge or mid-Atlantic ridge. When it's moving like this, it kind of moves the soil or the crust on this way, and this move this way because convection is done on the other side. Now that's very, very short explanation about how it goes, because this goes up here due to pressure, and then the convection makes it move on the side. We have evidence of that happening in the Mid-Atlantic Ridge. That's the easiest way to see it, and it's very, very, very evident when you look at it. Anyway, all this said, you can go and click on the links below here for this video so that you'll be able to watch this video. Important to do, but it explains the whole thing here. So if the continent moves, right? So Wegener noticed that Africa and South America, if you look at South America and Africa here, so if you look at the two, they fit pretty much like a puzzle. So, and then he wondered, and if that was for all continents? Later, with all the new technology like computers and sonar and all those things that we use, LiDAR that we use also, we were able to create models from what the Earth should have looked like during Pangea time. So the idea was, okay, so if those were connected at one point, then if this was connected at one point, and here, one was a little bit closer than that, but whatever, and all of this, if that actually was like that at one point, why, how, like, where did that all start from? Like, if we are all separated and it moved, this is, with the computer, we were able to come back to this picture here, if you want, of what it should have looked like. So maybe it's right, maybe it's wrong, we don't know, because none of us were there at that time. So that's the idea. As we got more and more advanced, we were able to create the different steps of the continental drift and extrapolate or predict what might happen in the future. And here is what it looks like. So if you click on that link that will be below, it gives you an overview of what it was, like the Pangea, starting with the Pangea, and we are able to somewhat predict what it will look like in 100,000 years. So this is pretty much what it does here. Just go with what we think might happen. So now this is all fun and dandy, but in science, we also need some evidence to support any claim, right? So this is the evidence. You will find here the evidence of the continental drift. So again, down there, you'll have all your the links that you can go and click and be able to listen. It's copyright, I can't do that here. So what else? The discovery of the mantle convection led to another concept that was now easier to explain. So that concept is the rock cycle. The rock cycle is a basic concept in geology that describes the transition through geologic time among the three main type of rocks: the sedimentary, metamorphic, and igneous. And the two videos here, well, actually there's three. I said two, but there's three. Well, anyway, there's two videos, which is true. Two video and a graphic, but whatever. And it explains the rock cycle. You can use any of the two, okay? But the song is actually pretty funny. I like the song. It's pretty good. And then a 3-minute explanation of, so either or, okay? You can watch both and then you decide which one you prefer to go to listen. And then there's the graphic here that you can always go to also, and then you choose the one that is best for you to understand the rock cycle, because guess what, it will come back. And that's pretty much it. And the graphic is here also, is fairly well explained. It's very basic, but still good. And our questions. So who was the first to talk about the continental drift? Who developed the idea independently? And what helped to get the theory accepted? This should be easy. What are the evidence we have about the continental drift? 2 or 3, and this would be in the videos. And explain briefly the rock cycle. Again, it's fairly simple to explain. In the videos, you'll see it, and then you can put it in your own words. And this is the end of your Unit 4, the continental drift. So that was a short and easy one. Alrighty, take care, and see you later.